Responsible AI is more than good intentions. In this topic, we'll turn fairness, explainability, and transparency into practical tests, documentation, and evidence, so AI systems can be monitored, governed, and trusted throughout their lifecycle. We've already built the security foundation: architecture, identity, application controls, cloud posture, detection, response, and governance. Now we extend that foundation into assurance by asking whether AI behaves fairly, transparently, and responsibly in real business contexts. Assurance is the bridge between values and evidence. Principles like fairness, transparency, accountability, and human oversight only matter when they become repeatable controls. That means testing models for bias, checking explanations, documenting decisions, assigning governance ownership, and monitoring behavior after deployment. The goal is not simply to claim that a system is responsible. It is to prove it with measurable results and auditable records across the AI lifecycle. Before choosing a fairness metric, define what you are testing and why. Start with the AI use case and the exact decision being made, such as loan approval or hiring. Identify who is affected and what harms could occur. Then name sensitive attributes and possible proxies, including location or language. Finally, classify the bias risks: direct, historical, measurement, or deployment related, and translate them into clear fairness objectives. Fairness results are only as trustworthy as the test data behind them. A strong evaluation set should reflect who will use the system, where it will operate, and the unusual cases that may expose hidden failure modes. Check coverage across demographics, languages, regions, and usage patterns. Also, test label quality, missing data, bias, and imbalance. Keep fairness data separate from training when possible, and be explicit about gaps, limits, and uncertainty in the final assessment. Protected attributes like age, gender, and race are often the starting point for fairness testing. But a model may never see those fields directly and still reproduce bias through proxies such as zip code, school, device, language, or purchase patterns. That is why intersectional testing matters. Risk may be invisible for women or older users alone, but clear for older women in a specific location. Collect attributes carefully. Enough to audit fairness, but not so much that privacy or legal risk increases. Different fairness metrics answer different questions. Demographic parity looks at selection rates. Equal opportunity and equalized odds focus on error rates, such as false negatives or false positives across groups. Predictive parity and calibration ask whether scores mean the same thing for everyone. These goals can conflict, especially when base rates differ. Choose metrics from the harm model, justify thresholds, and review them with legal risk and business stakeholders. Once disparity metrics are calculated, interpret what they mean in practice. Compare outcomes like approvals, denials, rankings, or escalations across groups. Then examine error patterns. A false positive may wrongly penalize someone. A false negative may deny a real opportunity. Before acting, check sample sizes and confidence intervals. If the disparity is reliable and high impact, escalate it to governance, legal, risk, and business owners for remediation. Bias testing is a spotlight, not a floodlight. It reveals measurable risks, but only within the data, labels, assumptions, and populations included in the test. If protected attributes are missing or restricted, conclusions become less certain. Even strong results can decay after deployment as users, data, or models change. And statistical parity does not automatically resolve ethical or operational harm. Every assurance report should document what was tested, what was not, and what residual risk remains. When fairness testing finds a disparity, the response should be controlled, not improvised. First, identify the root cause, then choose a remedy. Improve labels, rebalance data, constrain features, tune thresholds, or adjust the business rule. High-impact systems may also need human review, appeals, and override paths. Before release, governance checks the trade-offs. After implementation, retest against the old baseline for performance, fairness, and security, then keep monitoring for regression. Explainability is not one-size-fits-all. Each stakeholder needs enough information to act, but not the same information. Users need clear reasons, notice, and a path to challenge or escalate. Business owners need assurance that outcomes match policy, risk appetite, and customer commitments. Auditors and regulators need documented rationale, evidence, limitations, and ownership. Technical teams need deeper diagnostics to investigate errors, drift, bias, and unexpected behavior. Good governance designs these explanation artifacts by audience from the start. Explainability is also a toolkit, not a single technique. For structured models, feature importance, SHAP, LIME, and counterfactuals can show which inputs influenced a decision. For vision or language systems, saliency maps, examples, citations, retrieval traces, prompt logs, and guardrail records add context. But complex neural networks, proprietary foundation models, ensembles, and agent workflows may remain partly opaque. In those cases, be explicit about limits, validation evidence, uncertainty, and compensating controls. Transparency matters for everyone affected, not just auditors. Users should know when AI is involved, what factors shaped a decision, how reliable the output is, and what recourse exists. Oversight also has to be operational, not symbolic. Define who reviews, who monitors, and who can command a stop or override. Then give those people the training, tools, authority, and time to escalate, intervene, and record what happened. Documentation is not paperwork at the end. It is the evidence trail that follows a system through development, deployment, monitoring, and review. Model cards explain what the model is for, how it was evaluated, and where it should not be used. System cards connect that model to real data flows, controls, and dependencies. Risk assessments, monitoring logs, incidents, and audit records keep governance current as conditions change. Bias testing, explainability, and AI documentation create the assurance layer for responsible deployment. Together, they help prove that systems are fair, understandable, and governed with evidence. Next, we build on that foundation with legal and compliance controls, then business continuity, manual override, and human factors for resilient AI operations.